Hello and welcome to today's webinar on fast food restaurant optimization. This is being brought to you by Siemens Digital Industry Software and our consulting partner, Design Systems Incorporated. A few housekeeping items to go over. First off, this session will be recorded. It will be available at a later date. Also, if you have any questions anytime during this presentation, feel free to hit on the Q&A tab and type in your question. If we have time at the end, we will answer those questions. And any questions not answered at the end, we'll follow up with at a later date. Now, for introductions, I'm Mike Walker. I'm a portfolio development executive with Siemens Digital Industry Software. On the upper right is my coworker, John Keithley. He is a product support specialist, also with Siemens Digital Industry Software. On the bottom left, we have Gabriel Carreno. He is the simulation team manager at Design Systems Incorporated. And on the bottom right, we have Amanda Moore. She is business development, also at Design Systems Incorporated. So with that, I'm going to turn it over to John Keithley.
Thanks, Mike. Hello, everyone. Thank you for taking time today to join our webinar. I'm going to introduce Siemens here if you're not familiar with us. Siemens AG is a multinational corporation with over 300,000 employees. We have 6 business units. Our business unit is Digital Industries. Our other units include Smart Infrastructure, Mobility, Siemens Advanta, our portfolio companies, and Siemens Healthineers. Within these business units are divisions. Our division is Siemens Software. Other divisions in our business unit are Factory Automation, Motion Control, Process Automation, and Customer Services. Siemens is unique in our space as we are not only developers of software, but we also consume our software of manufacturers of our own products. Siemens has made a great investment, over $10 billion since 2007, in creating the industry's leading digital twin. We have close to 13,000 engineers shaping this digital transformation and connecting the real and virtual worlds. We call this our Siemens Accelerator portfolio, with capabilities for mechanical and electronics design, simulation, manufacturing simulation, which is part of what we're discussing today, operations, IoT, applications, and collaboration. Siemens Accelerator is a comprehensive digital twin that is personalized, adaptable, and modern. It is a flexible, open ecosystem, and we have solutions that can stand alone, or connect with your existing systems, or connect with new solutions within our portfolio and with your existing systems. Now I'd like to introduce Amanda Moore from our partner, DSI.
Thank you, John. Design Systems is a privately owned manufacturing engineering firm with 40 years of experience in world-class manufacturing. Our success has been achieved through building long-term relationships with our customers and becoming an extension of their internal teams. Today, we have almost 300 engineers and technical support personnel. Our core focus is on data-driven solutions, including 30 years of experience in dynamic simulation. DSI is headquartered in Farmington Hills, Michigan, in the greater Detroit area, and we have regional offices in Canada and Mexico. Additionally, we have supported our customers across the globe. While DSI's roots are based in the manufacturing industry, our expertise transcends across every segment of services, including restaurants and fast food. Our company is divided into 5 core engineering disciplines. This depth of engineering talent is essential to dynamic simulation and root cause analysis of complex challenges in the workspace.
So let's take a look at some of the challenges facing restaurants today. First is optimizing staffing levels. As we all know, throughout the day, you've got your high demand periods, breakfast, lunch, dinner, and then in between, maybe lower demand. So how do you optimize the staffing levels throughout the day? Next, how can you optimize performance, whether your customer is coming through the drive-thru, the front counter, or to utilizing mobile services? Can changing the equipment layout improve the overall efficiency? And how can you optimize equipment utilization? Could adding additional equipment improve performance? The ultimate goal is to improve customer satisfaction and improve the speed of service. So what changes can you make to improve both? And what would be the effect of changing worker tasks? For instance, if you have a worker who is assembling sandwiches, could they also manage the fryer? So let me turn this over to Gabrielle.
Thank you, Michael. I would like to start with some background and functionality of the simulation model. The QSR dynamic simulation model that I'll be presenting was designed to be highly adaptable, allowing for rapid assessment on how changes in the restaurant process menu, equipment, and layout design affects the system labor and equipment utilization, deployment quantity, throughput, and speed of the service. Now, this simulation model was built around optimizing staffing levels and scheduling to maximize throughput while still keeping a short delivery time, which is something key in the QSR industry. The simulation model was specifically designed to incorporate drive-through, front counter, and mobile customers, as well as they have the option to run real-world data to understand typical daily, weekly, and monthly operations, as well as the statistical distributions to analyze restaurant performance metrics such as customer arrival patterns, items per order, and menu items, just to name a few. This simulation model has the ability to vary the number of workers and their assigned tasks throughout the different parts of the day, allowing for a more accurate simulation of the actual restaurant operations. And this is going to enable the user to run extensive what-if scenarios to assess the impact on the staffing level decisions on throughput and speed of the service.
Now, this simulation model was built using Siemens plant simulation, which is a great dynamic simulation tool that allows the user to develop complex simulation models such as the one that you're seeing on the screen. This simulation tool allows for the 3D animations that you're seeing, plus all the building blocks to build complex logic to kind of move all these pieces around. Now, there's two major areas of the simulation model. The left-hand side controls all the inputs and outputs. Now, if I zoom into that area, we're going to be able to see all the data files that are actually feeding the simulation model with the right information. We can see at the beginning here some toggles if you want to turn on and off certain functionalities such as drive-through lanes, drive-through windows. How do you want to run the simulation? If you want to run with a statistical analysis or you want to run with actual data from the restaurants. As I mentioned, all the cycle times that you want to input in the simulation, such as the speeds, especially on the worker side, like walk speed, like how much time they spend picking up the orders, how much time taking up the cash. All that information will be in this area. Menu items, all the different items that they have in the restaurant. It goes from forks, napkins, all the way to complex items such as like burgers that requires a lot of steps to be able to finish one of those items. These menu items also has all the routings, like all the process that they need to follow, along with the cycle times per station. So how much time it takes to assemble the burger, how much time it takes to wrap the burger, how much time it takes to provide the burger to the person that is going to consolidate the order. All these times are going to be included in the menu items table. Then finally, we have one of the most important, which is going to be the deployment. You're going to end up specifying how many different parts of the day that you have. In this case, we have 5: breakfast, lunch, afternoon, dinner, and late night. And how many workers you have working the shifts. So right now I have 6 on the first 2 and 5 on the last 3. Now, apart from that, once we complete the run, we're going to be able to see some of the reports that I'm going to be checking with you in a few minutes. If we go to the right-hand side, we have the actual simulation model with all the 3D objects. Now right away we can start seeing the flows that I was telling you before on the background. We have the front counter customers that are going to be using this section here on the top. They're going to be entering the simulation, going into the front counter, asking for their items, and those front counter persons are going to be sending those items to the back, as you can see right now. Once they define the order that they want, they're going to be standing up in this wall here until they finish the order, so they can come back, get into the front counter, get the orders in their hands, and then at that point in time they're going to make a decision whether they stay to dine in or they just take the order out. So you can see right now this person decided to dine in, this person might just decide to leave the simulation. Apart from this flow, you're also going to see some customers that are going to arrive into the simulation model using the same door here on the top, but instead of going to the front counter, they're actually just going to go into this cabinet area here. Now this cabinet is just for the mobile customers, and we're assuming the mobile customers already paid for the order. They already placed the order a couple of minutes in advance, so the order should be ready in the cabinet, so they're just going to go and pick them up and leave the simulation. Apart from that, we also have the drive-thrus. Drive-thrus are going to enter from the left, and they have two options. Either if they're mobile customers, they're going to be using the left lane, where they're just going to stand for a few seconds, check in, and then just drive to pick up the orders, because again, we're assuming they already order and pay for it. But if they're just a normal drive-thru, as you can see right now, they're actually going to stay here, order the items, and then go and wait for the items to be made, right? So here's where they're going to stand until the worker here delivers the order to one of them so they can leave the simulation mode. Now, apart from the different type of customers, you also have the kitchen. The kitchen is the one driving the whole simulation, right? So if I zoom into this area, we have some workers here that you can see right away. Right now, depending on the shift, remember we have 6, 6, 5, 5, and 5. So right now we have 5 customers, 5 workers actually doing all the orders. So they might be wrapping, they might be assembling, frying items, grilling items, because if they're not building, they're actually grilling or frying to keep up the stock of the things that customers are going to be requesting. So as of right now, people are just assembling items, finishing up the items. Someone from the front is going to consolidate everything into a bag, so he can deliver the bag either to the drive-through customers or to the front counter customers. So on this section here, we also have areas such as like the coffee machine, the shake machine, the soda machine. All these are going to be part of your orders. So some customers are going to arrive, they're going to request a few assembly items, or they're also going to request some sodas and some shakes. So that's the purpose of these sections here. And then depending on how you define your workers, they're going to be either just doing one specific task, like this person here, which is only picking orders, or they might be just running around the restaurant, helping each other, finishing up assembly, wrapping, toasting. It depends on how you set up the simulation, and this is one of the beauties of this type of simulation, that it's very flexible and it allows you to understand different type of flows. So with this in mind, I'll just go back into my main view here and explain a little bit of what this simulation is all about. I mean, right now, as I mentioned to you, one of the key metrics of this type of simulation is understanding the speed of service. For now that I have included a couple of dynamic charts that plant simulation allows for on the top, and right now we see that we're working during late night. We're in the late night shift, and right now the overall speed of service is at around 4.1 minutes. I have set up this chart to tell me the threshold, which is 4.5, 4.6 right now for this type of restaurant. And we're seeing on the screen that everything looks okay except for afternoon and dinner. Those afternoon and dinner are exceeding a little bit the threshold. They might be going to 5 minutes or a little bit beyond 5 minutes, which is something not acceptable at this point in time. this is telling me that we don't have enough workers for this to shift, or I haven't assigned those tasks correctly. I still don't know at this point in time. One of the easiest type of what-if scenarios that someone can do is just open the tables and change the customers and the workers, right? So what I'm going to do here is I'm going to fast forward my simulation. I'm just running it for 3 days because I also want to show you some key metrics that I get from the simulation. So this is done, it's done running. So we can see some of the charts that the simulation is providing. In this case, I'm displaying the operator utilization. So we can see how my workers on the kitchen are utilized. I mean, we see the fryer as expected is really high. He's the one always walking around. And as expected during afternoon and dinner, I see a spike, especially in the afternoon, on the amount of work that I have. But overall, it seems okay. Assembly seems around 50% utilization, maybe 60 during afternoon, which is one of my major concerns right now. This is usually the one driving my speed of the service, the assembly person. So one of the things that I'm going to do here as experimentation is that I'm going to open the deployment table that I showed you at the beginning, and I'm going to modify these, and I'm going to send 7 workers during afternoon and 7 customer workers during dinner. So with this information, I should be able to reset the model and rerun it. And for now, I'm just going to rerun it for like 2 days so we can stop it and see how the system is behaving. So we're about the mark of 2 days. So what I'm going to do is stop it. And we right away see that my metrics are a little bit better. Right now we're working on breakfast, and we're seeing an overall speed of service of 3.8 minutes, which is way better than the 4 that I was seeing before. But the major thing will be that all my shifts are below the threshold, which is what I wanted to achieve. Now, at this point in time, the user can start experimenting because it seems that I have some room for improvement here. I'm not at the threshold level, so I might be able to reduce the number of workers and increase it in some other places, because this one is still a concern. It's too close to the threshold. You might exceed it if you get a little bit more customers. So it's for a debate over there, and that should be one of the decisions that the user is going to be taking on what's going to be the best number based on the experimentation that you do. But right away you can see the impact of using this type of simulations. We are making decisions, we're running experiments without a lot of cost. Once you have a simulation built, you can run as many experimentation that you want without really applying anything in real life. So another thing that you can do with this type of simulations, as I mentioned before, if I zoom into the kitchen, and you want to further analyze the utilization of the workers, it's possible by just breaking it apart and just checking how much they're walking. Sometimes how much they're walking tells us that the layout might be not efficient enough if they're walking a lot of distance just to get into the fryer, right? So that'll be another point of improvement that you can have with this type of simulations, changing layouts and see if there's going to be an impact of moving the fryer from one location to another. Some of the things that you'll be able to see is the dining area, and understand if you have enough space for the dining room, specific to each restaurant, because it will depend a lot on the volume. And of course, as you saw it already, you will be able to run different statistical distributions, maybe increasing the customer volume depending on the restaurant that you're trying to analyze, and see how many people you need to hire, if the restaurant is capable enough to run that many transactions, and if you're keeping the speed of service to a certain threshold. So with this, I conclude the demo of the fast food simulation. Thank you.
So, what are some of the values and benefits that you saw through this demonstration? The most important thing is being able to make informed decisions. So you want to be able to assess the impact of changes you are planning to make to improve the speed of service and increase customer satisfaction. And the way to do that is to virtually simulate those changes before you actually implement them. The other is taking advantage of historical data to be able to leverage that to help drive and improve changes within your restaurant to minimize costs, improve quality and service. Also, the ability to test new strategies in a virtual environment before actually making those implementations. And last, to enable continuous improvement so that as customer demand changes, you can adapt while improving efficiency. ABI Research is an independent research company, and they did an analysis of the top 7 simulation tools in the market space, and they rated Siemens as number 1 in the market. So with that, we have some time for questions. One thing I'd like you to keep in mind, if you find out at a later time that you need to contact someone, we'd like you to rely on 2 contacts, John Keithley with Siemens or Amanda Moore at Design Systems Incorporated. So with that, I'll take a look at some of the questions we have here. This first one would probably be for Amanda. If we don't have qualified simulation engineers on site, can you perform consulting services to help build the initial model? And what would that engagement model look like?
Great question. As a Siemens Alliance service partner, DSI can work with customers to develop a solution specifically tailored to their needs. From developing the model through experimentation and mentoring, we can help the customer really hit the ground running in plant simulation.
Thank you. Next one, I'm going to go to John for this one. Is training required, and what are the training options?
Thanks, Mike. We have multiple training options and a customer best practice. This best practice is based on a combination of both the consulting services Amanda mentioned and our formal classroom training, either in person or virtual, and paired with a self-paced on-demand online training that you can reference if you have any questions after any type of formal classes or after the consulting with DSI.
Thanks, John. Let me address one last question. How is Plant Sim licensed, and do you have different levels of capability? In terms of how Plant Sim is licensed, we have named user, which is assigned to a single user, or we have concurrent, which allows a license to be shared by multiple users. Both of these options are 3-year subscription models. Plant simulation is available with numerous levels of capability, starting with a simple solution for non-simulation users to run simulations, all the way up to our professional solution, which has full capability for high-end simulation engineers. This enables our customers to start at a level appropriate for their needs and scale as demand increases. We will follow up with the remaining questions that we have in the queue directly with you. On behalf of all of us, we would like to thank you for taking the time to attend this webinar. Again, if you have additional questions after this, please reach out directly to either John Keithley or Amanda Moore. Have a great rest of your day. Thank you.